Hi, I am Dr. RUSHI, Associate Professor in the Department of Mathematics, Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. Today we are discussing COSM, Computer Oriented Statistical Methods. In this subject, we have to discuss the first one is probability. Basically, we are discussing random variables and binomial something Poisson distributions. But before that, we have to discussing first of all introduction to probability. Okay. Next, before probability of the definition, we have discussed a few examples of the some basic definitions. Okay. First one is experiments and outcomes. So, an experiment is a process that generates well-defined outcomes. Okay. Example: tossing a coin. If you toss a coin, you will get the result of 2-1. That is head and tail. Okay. Head and tail. That is sample space. Okay. So, rolling a single dice or pair of dice. If you roll a single dice, you will get 6 outcomes. That is 1, 2, 3, 4, 5, 6. These are the outcomes. That is 1, 2, 3, 4, 5, 6. And applying for a job, you will get or not. We don't know exactly. That is applying for a job. That is also one experiment. Salary expected after completing a degree. Okay, we don't know what exactly salary we have to get. Next, drilling an oil well and federal elections. Some elections are joining, so we don't know exactly which party are success or not. Okay, these are the examples of the experiment. Okay, next, random experiment. So, if an experiment is conducted any number of times under essential identical conditions, there is a set of all possible outcomes are associated. Okay, if the result is not certain and any one of the several possible outcomes of the experiment is called a random trial or random experiments. Okay, the outcomes are known as the elementary events. Okay, that is random experiment. And next is sample space. The sample space means the set of all possible outcomes in a event is called a sample space. So for example, we can toss a coin, you will get head and tail. Head and tail are the sample space. In the sample space, we will get head and tail. Okay, each element of a sample space is called sample point. Okay, any subset of a sample space is an event. Sorry, anyone is event. The sample space is denoted by capital S. Yes, we represented capital S. Sample space is denoted by capital S. Example: if a coin is tossed, then the sample space is S equal to head and tail. That is okay. That is outcomes are head and tail, H comma T. So the total sample space is S equal to H comma T. If you're rolling a single die, the sample space is, so if you roll a single die, you will get 1, 2, 3, 4, 5, 6 numbers. That is S equal to 1, 2, 3, 4, 5, 6. In case 2, if you roll a 2 dice, you will get 36 outcomes. Like 1 comma 1, that is 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. Like next 2 comma 1 like this. So finally the last one is 6 comma 6. That is overall 36 outcomes are there. That is if you die 2 dice. Okay, that is. Next, equally likely events. Some definitions are there. Equally likely events. All are equal. Events are said to be equally likely events when there is no reason to expect any one of them rather than any one of the others. So all are equally likely events. If you toss a coin, you will get H comma T. H and T are equally likely events. Both are equally. Okay. If you throwing a dice, you will get 1, 2, 3, 4, 5, 6 numbers. All 1, 2, 3, 4, 5, 6 are equally likely events. Okay. That is example. When throwing a die, any number may be obtained. In this trial, all the 6 elementary events are equally likely events. All are 6. 6 means 1, 2, 3, 4, 5, 6. These 6 are equally likely events. Okay. Next, exhaustive events. Exhaustive events also. All possible events in a trial are known as exhaustive events. For example, in tossing a coin, there are 2 exhaustive elementary events, that is head and tail. If you toss a coin, you will get head and tail. Both head and tail are exhaustive events. If you throwing a dice, you will get any one of the number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 are all are exhaustive events. In throwing a die, there are 6 exhaustive elementary events. That is either 1 or 2 or 3 or 4 or 5 or 6. These 6 are exhaustive events. Okay, that is. Next, mutually exclusive events. So, events are said to be mutually exclusive events if the happening of any one of the events in a trial excludes the happening of the others. The events are said to be disjoint events. Okay, that is mutually exclusive events means if you toss a coin, you will get head and tail. Head and tail are both are mutually exclusive. If you get head, you don't know tail. You didn't get tail. That is okay. So events are said to be disjoint events. For example, you can take any H and T in a set S equal to head and tail are mutually exclusive events. That is the intersection of the head and tail equal to 0. That is null set. Okay. Intersection of the H and T are 0. That is a null set. Okay. That is disjoint sets. Disjoint sets. That is a, you can also write in mathematically phi. Okay. Example, if A and B are 2 events in a trial is said to be mutually exclusive events, then the intersection is empty. Empty means that is phi. Okay, that is mutually exclusive events. And finally, the definition of probability. So here we have to explain the definition of probability. In a random experiment, already we know the definition of random experiment. Okay. In a random experiment, n mutually exclusive and equally likely events. Okay. Let capital E be the event of the given experiment. If small m be the elementary events favorable to E, then the probability is defined by, therefore, P of E equal to, that is, number of events favorable to E is divided by the total number of events in the random experiment. This is the definition of probability. Probability is number of favorable to E divided by total number of events in the random experiment. Here m is the favorable cases, that is m, and n is the total number of events in the random experiment. So the definition of P of E equal to m by n. That is. So out of total number of events, we have to take any favorable cases. That is the probability m by n. Okay. And also some note we have discussed. So probability is always lies between 0 and 1. That is 0 less than or equal to P of E less than or equal to 1. So probability is always lies between 0 and 1. Okay, not more than 1 also. Okay. So if probability equal to 0, this is an impossible event. At least something values are given. Okay. In case probability equal to 0 is there, that is the impossible cases. Okay. In case probability equal to 1, then the event is certain event. Okay, successfully. And also we have discussed axioms of probability. There are 3 cases are there. 3 cases. First one is axiom of probability. Axiom of probability is always positive. So P of E greater than 0. And axiom of certainty. Total probability, P of S. S is a sample space. So P of S equal to 1. Total probability of the sample space is 1. and axiom of union. Here, if A and B are two disjoint subsets, disjoints means intersection is empty, disjoint subsets of S, then P of A union B equal to P of A plus P of B. Okay, P of A plus P of B. That is, in case here the two sets A and B are disjoint subsets. Okay, these are the axioms of the probability: axiom of positivity, axiom of certainty, and axiom of union. Okay, these are the properties of the probability. Okay, so these are the basic definitions of the probability. Now we have to discuss a problem, a small problem. Okay, you see that the problem is a class consists of 6 girls and 10 boys. If a committee of 3 is chosen at random from the class, find the probability that the first point is 3 boys are selected, and second one is exactly 2 girls are selected. So here you have to use the probability definition. Okay, a class consists of 6 girls. So now you see, given you see the problem, write down the solution. Given girls equal to 6, boys equal to 10. So finally, total number of students equal to 6 plus 10, that equal to 16. So total number of students are 16 are there. So, and if a committee of 3 is chosen at random from the class, a committee has selected 3 persons. Okay, 3%. Find the probability that in these favorable cases, our first point is 3 boys are selected. Only 3 boys are selected. That is first case. Second one is exactly 2 girls are selected. So committee has chosen three members. If you selected 2 girls, definitely the other person is third person is boys. Okay, 1 boy and 2 girls. These are the favorable cases. Find the probability. Okay. Now we have to find probability equal to P of E equal to M by N. M is a favorable cases. N equal to total number of events in the random experiment. First we have to find N. N equal to number of ways selecting 3 students from 16 students. That equal to, out of 16 we have to selected 3 is 16C3. You know that 16C3 16C3 means it is a combination. Okay, we know combination and permutation. Let us discuss it. Okay, so combination is NCR. NCR is a combination formula. Out of n objects, we have to select only r objects. That is NCR. NCR equal to n factorial by n minus r factorial into r factorial. NPR also, permutation, NPR. Arrangement we can use in permutations. NPR means n factorial by n minus r factorial. These are the important formulas. Okay, generally you can use. Okay, so 16C3 ways, that is n. Next, first one is 3 boys are selected. 3 boys are selected. Okay, already we know n value. Now we have to find m value. M is number of ways selecting 3 boys from boys. Total boys are 10. From 10 boys. 10 boys is m equal to, out of 10 selecting 3. 10C3 ways. That is 10C3 ways. Okay. So already this is we can take, this is m1. Okay. M1. First case. Okay. First case we can take M1. Therefore, next E be the event of the selecting a three boys. Okay. So now we have to write. Therefore, let capital E be the event that selecting three boys. Therefore, P of E M1 by N. You see, here M is 10C3. Therefore, 10C3 divided by 16C3. Now using the formula. So 10C3 means 10 factorial by 10 minus 3 factorial into 3 factorial. We can write that is 10 factorial by 7 factorial into 3 factorial. We can simplify this 10 into 9 into 8 into 7 factorial by 7 factorial into 3 into 2 into 1. 7 factorial are cancelled. Okay, simply you can cancel. So we can write here that is 10 into 9 into 8 divided by 3 into 2 and also divided by same 16C3 also. 16C3. 16 factorial by 16 minus 3 means 13 factorial into 3 factorial. That is 16 into 15 into 14. 13 cancelled. 3 into 2 into 1. That is simply you can write 16 into 15 into 14 by 3 into 2. Okay. So 3 into 2. 6 are cancelled. Finally you will get 10 into 9 into 8 divided by 16 into 15 into 14. After simplifying, you can write 3 5s are, 3 3s are, 5 1s are, 5 2s are, 2 1s are, 2 7s are, 8 1s are, 8 2s are. So 3 by 14. Okay, the probability is P of E 3 by 14. That is first one. Now the second part is exactly 2 girls are selected. This means the committee has chosen three members. Already there are 2 girls. The remaining person is boy. So 2 girls and 1 boy. Here the favorable cases M2. You can take M2. M2 means 2 girls out of 6 girls. Okay. 6C2 into boys are 10C1. 2 girls and 1 boys. That is 6C2 into 10C1. That is M2 favorable cases. Therefore, the probability P of E2. You can write this is E1. This is E2. M2 by N. That is 6C2 into 10C1 divided by 16C3. So as usual you can write 6C2. So here you can using the combination formula. 6C2 means 6 factorial by 6 minus 2 means 4 factorial into 2 factorial. That is 6 into 5. 4 cancelled. 2 1s are, 2 3s are. That is 15. So 15 into 10C1 means 10 divided by 16C3. So 16C3 already we know the simplifying 16C3. This is 16C3. That is 16 into 15 into 14 divided by 3 into 2. 3 into 2. So now simplifying this one. 15 already you know the simplification. 2 1s are, 2 7s are, 3 1s are, 3 5s are. Therefore 15 into 10 divided by 16 into 5 into 7. Now simplifying this one, 2 8 0, 2 5 0, 5 5 cancel. Okay, so finally 15 by 8 7 0, 8 7 0, 40, 56. 56 is the answer. That is P of E2. The probability is 15 by 56. So these are the way to have to find the problems by using probability. Okay, these are the simple problems we have discussed. Okay, now so we are using the references. These are the references of the even introduction to the probability. Okay, next class we can discuss random variables. Basically, the random variables are the important in the COS subjects. Okay, so before going to the random variable, we have just to discuss the probability. Okay, so next class we can discuss random variables and types of random variables, discrete random variable and continuous random variable, and we have discussed a few more problems. Okay, thank you.